Hello, it's Terry again from Real World Boating. I'm going to talk about windlasses today. Here's my windlass that I'm getting ready to install. It's not fastened down, as you can see. I can move it around. I'll do that in a later video, but I did want to check it. I did work on it and get it all cleaned up. I purchased it used. It's an RC Plath number 5B. It is a bronze windlass, as you can see back here. They do make an aluminum one as well. The 5B is really heavy. It's like 120 pounds for this windlass. I really like the fact that it is bronze, and I have kind of a mix on my boat of both bronze and stainless. So it doesn't really matter, and I will eventually paint it white. I've been told by a lot of people have been using windlasses in the tropics when it's really hot, that the darker color for the bronze will make it so hot that it can shut down and then damage the motors on the windlasses itself. So it's a 12 volt DC motor. It doesn't have the remote the remote control on it. It is a manual, so there's a switch right here, up and down, or not down. It's just up. To make it go down, you would loosen up the friction brake, and then it would spin, and it could go down. I did purchase a stainless steel chain as well. And I have 200 feet of stainless steel chain, and I have another 150 feet of rode. It is a Amsteel, essentially, rode after that, with a stainless steel thimble and a stainless steel shackle connecting those together. And one of the reasons why I spent the extra money, which is quite a bit more, about 3 or 4 times more for the stainless steel. This is a 3/8 chain. The reason why I spent the more money for that was because it flakes out better in your chain locker. I've had some people tell me that by using a hot dip galvanized chain, the rough hot dip galvanizing on the surface will make it so it doesn't flake. It sort of piles up, like a stalactite, I guess. And so it'll just build up and pile, and then it'll get to the top of your chain locker, and then it can get bound in your winch if it doesn't fall down into your chain locker properly. Although this chain locker in this is huge. You could probably put, like, I don't know, 1,000 feet of chain in it. It is really large. Probably in future I might figure out something else to do with that extra space or something. But as you know, if any of you are boaters yourself and have dealt with chain lockers, it is a very moist environment. It does have a lot of corrosion. That's another reason why I wanted to go with the stainless steel. This is 3/16 stainless steel that I got. Really good price on that. I think it was on the order of about $2,000 or something like that for that 200 feet of stainless steel chain. So it was a pretty good price for that, even though $2,000 is a lot of money. For me it is anyways. And then I have a 75-pound Bruce anchor right now, and I do have a couple. I have a Delta and a Danforth for this as well. And so yeah, it's good to have multiple anchors, especially sometimes you'll be in a situation where you want to do a stern anchor and your bow anchor, and a lot of times you will use your the front of your boat to set your stern anchor, because you can get a better tug on it and that type of thing than you can from the stern, and it's easier to deploy, but it just depends on what you're doing, especially up in Canada, the Canadian waters. A lot of times they'll have really sheer rock faces along the British Columbia coast on the Pacific, off of north of Vancouver Island. Usually not on Vancouver Island itself, on the mainland. There's a lot of places that will have rings that are like bolted into rock faces, and it's a sheer face that continues really deep. Almost fjord type situations on the British Columbia coast there when you're boating up there. And so a lot of people will take and stern tie just a line to that ring. Usually it's just you push it through and you tie it twice on your boat. So when you release, you can just you have to dinghy up to it, of course, unless it's a super calm day. It does go down really sheer off of a lot of these faces, so it's immediately, 30 feet deep, oftentimes at least. So it's not that big a deal, but you wouldn't want to get it crashed into a rock face or something like that. So usually boats will dinghy up to it, get a loop on, and then bring it to the stern of the main boat. And so you're pointing one direction all the time. You don't swing. And then you can set your anchor and all that type of thing. So there's a bunch of different variations on stuff that happen, especially if you go cruising and you're in different anchoring situations, like potentially all over the world. You do need versatility. I do like this anchor. It is, as you can see, it is a horizontal anchor. Is all on deck. The motor is on deck. I really like that feature. It's easy to get to. You have to crawl up and open up cabinets and get into your chain locker and work on something in a really moist, wet environment. So I like the fact that it's up here. It's you're able to get to it and maintain it. Yes, windlasses do require maintenance, as do everything else. And so they do have the vertical windlasses that you see around quite a bit, actually probably more popular than the horizontal ones nowadays. These horizontal windlasses with the capstan on one side and the chain gypsy on the other side used to be more popular, but now in modern areas, say in the past like 30 to 40 years, the vertical ones, and oftentimes you'll have the really fancy ones that'll be flush, and then you basically are all automatic, where they'll deploy out and then you hook your chain up on the gypsy. Other ones are just static and mounted there, which are the more popular style, that are static and sit there. Some of them have the actual the lines and the chain gypsy all in one, so you can put your rode in it and winch that up, and then your chain gypsy will bring it up as well. So yeah, I'm going to be installing this RC Plath windlass. RC Plath is a company that's been around forever. I think they started making windlasses in the 20s, and so a lot of boats have these. They're still in business, believe it or not. You can go to their website. I think it's just rcplath.com or something like that. You can, I don't actually know what the R and the C stand for. I think it's somebody's name, but R, Romeo Charlie Plath, P-L-A-T-H. You can go to their website. They don't have products that you can just buy online. You have to call them. It does have a products page and some PDF files of stuff that they've had in the past. But yeah, it's a good, it's a really good company, and they still will make service parts for, I can get a new gypsy, I can get a new bronze wheel or a bronze capstan. Inside the gearing, I actually talked to at length one of the guys that's been there for a really long time. I think he told me he'd been working them for like 35 years or something like that. And that they will supply parts and stuff like that. You do just have to either send a message or call them a lot and send several messages. It's like a machine shop, a metalworking shop. They do all kinds of things there, not just work on the old windlasses that they had. You do have to call several times because there's no, I don't think they have like a permanent office person type situation. It's the owners and workers themselves that are taking the phone calls. So you'd have to contact them, and then I recommend, just contacting them several times if you don't get a relatively quick response. I've had people talk to me online about how, yeah, they're a great company and everything, but they were not very quick to respond. And that's it is what it is. I don't fault them for that at all, but do just continue to contact them. But RC Plath, really well-known Pacific Northwest company. It's been here, like I said, since like at least the 30s. I think it was actually the late 20s when they started it. So a really good company. All right, I'm gonna put the battery in the box and then put the power cord for the windlass through the box there. I have these really nice, let me pull this back out of here. I already drilled the hole already, and I was just screwing it in for that right now. So let me pull that back out there. I made the hole really tight, so the actual fiberglass itself of the box, I just used a step bit on a DeWalt cordless drill to drill that hole. So I just measured it out, found the center, put it low, so this is pretty low, but not, you know, so low that it's going to hit, of course. And again, this is not mounted down either, so it moves around a little bit. And then I was gonna, it's a watertight seal, has a rubber connection on the bottom of it, so I'm just gonna screw that in for right now. Again, just showing you what I did, the process of it. Now, the battery itself, I'll show it inside the box after I get it all connected up. And then, actually put this in nice and tight here. And again, I just drilled it the perfect size so the threads would actually catch a little bit on that. And there's that. Emerald coming off now. So of course, put this on first, and then you can put the collet on there. It goes over the wire, and then I'll have to pull through the wire, of course. Twist some stuff out. I want this fairly slack. Get everything or approximately where it needs to be. Again, I just have spacers up because I am going to lift it up off the deck for wash to be able to run it underneath here. I don't want this to be a dam. I want water if it comes over the bow, if I'm in heavy seas, to be able to run underneath. About 16 inches beyond it, I do have an access to forward berthing, and so there's a couple of steps just so you can get up and climb out on deck there. It is somewhat of a skylight. It is UVing a little bit, but it is opaque because it is berthing. Typically in berthing, you can't just see right down into the stateroom or the head or anything like that, just because people might be naked down there, and so that's what's going on there. And so you get the idea. And then with these, I really like these type of wreck. It's all plastic, so nothing to no metal to rust out, and they are essentially waterproof. So rain and splash seawater. When I tighten this up real tight, it should actually seal that up completely. I will drill a couple of drain holes in the box, so if it does get any water inside, it's not going to fill up and float the battery or damage the battery itself. Just want to make sure that that's taken care of as well. Just going to continue tightening this up all the way to make sure that it's all sealed up really well. Seal around the hose, or the cord really well. And then open this up here, go inside. And then I found it did have this ring to screw on, but it's just steel, and it's got it's probably electroplated. It doesn't look like it's hot dip galvanized even. It's definitely not stainless. So I didn't want to use this. I don't know if you've ever seen that before. This will get all rusty in a couple years and then fall apart essentially. So what I did do is I got it's 1.25" pipe thread on the end of that wire support there. So go ahead and tighten that up also. Get my pliers adjusted to the right size here. Put a backup wrench on this on the outside so it doesn't unscrew it. Alright, we're gonna cut the wire here and get it ready to power up and test the windlass itself. So I'm gonna go ahead and do that. So I'll go ahead and cut it. I have these big shears for big wires. Kind of like a bolt cutter almost looking, but it is a shear, more like a scissor. It is rounded blades, as you can see that. So we'll go ahead and clip this wire. I'm going to need some length, so I don't want to shorten myself here. So cut it right about in there. Should be enough. It's really nice, easy to do. That type of thing. I take my razor knife here, and I'm going to need about 6 or 8 inches. Try to find, as you can see, the end of the wire. So there's 3 wires in the middle of the outside sheathing. So I like to look at in between. There's some insulation in there, and slice it down that so you're not going to cut the insulation for one of the interior wires. I'm going to cut it back about 6 or 8 inches so I have some length to work with here. And go ahead and split that open. Pull that out so I can get some separation, and just take the razor knife and slice right now. Now be careful on this part. It's real easy to go too far and damage the insulation of the interior wiring, so just be careful of that. And I usually like to score it and just kind of rip it. Usually it tears pretty easily. And so the outside insulation, and then go ahead and take the interior insulation, which is actually just to help the shape of the wire and to create separation, and also heat insulation, because sometimes the wires can get hot individually, so you don't want to have a meltdown and have one wire melt into another one. And to make it a nice round shape rather than a flat shape. They, specifically for a marine wire, you can find the really flat marine wire, and also I've seen it for direct barrier wire as well. So I do have 3 wires, and then the green is my ground. I use the black for the hot, and then it's actually, I guess, a dark brown, and then the blue is a backup. But I'm going to go ahead and put ends, terminals, for my battery on all three of these. So go ahead and strip it. Now this is, I don't have strippers the exact size. These are a little small. I'll grab some more strippers. I think this is a little bit larger. So this is 10 gauge stripper that I'm using. Oftentimes I will just use the razor knife, but I wanted to show how you can do both. You don't like really crank down on it. It's kind of just, you can almost feel it when it breaks it. And then what I like to do is pull it, make sure that it's all cut, and then twist it as you pull it. And that keeps the wires, all the individual strands, all together like that. And so it's all twisted and nice and fine, connected in there. So that's pretty good. So grab the appropriate size for my lugs. I'm going to check my battery real quick, see if that'll go on. That's a perfect size right there. So that is one right there. So we can get that all the way jammed down in there. And then I have the crimpers here. I do have these crimpers, which are pretty good. I also have these crimpers itself, which are really massive ones. So I'm going to set it with these, just because they're easier and handheld. And I have to use both hands. So I can get it set with these ones right here, going about in the middle, because I can see the strands like sticking through, so I'm all the way down. And then give it a nice crank to get that tight. And then grab the other ones. Get it into that last lug. Huh. Like I said, these ones are a little more awkward to work with. And go ahead and give that a nice crank there. And so that's really sealed up. And so that's nice and tight on there. And give it a pull. It's not twisting, it's not doing anything. It's sealed up there really nicely. And again, on the dark brown wire, I can use that as well. Oops, wrong one. And you can just feel it go clunk when you get through most of the sheathing. And then go ahead and do it another direction. And then, like I said, pull it to get some separation there. And then twist it to keep all those individual strands from the copper wiring together nicely. And then that same size. Again, that will probably just pull off again if I'm too aggressive with that. Open that up all the way. Make sure it's all tight. Go ahead and give that a crank also. Alright, so there's that. Got those tightened down. And the last one, I will strip it right now. And again, twist as you pull to keep all those wires together. Alright, so I'll move the camera, I'll get these connected up here real quick, and we'll ensure that all connected in. So. Alright, gonna go ahead and connect these up. So the green one's going to the ground, and then the washer on top, and then go ahead and, oops, tighten that down a little bit, and then the same thing for the positive, and then the washer. And then the standoff. Alright, so that's all connected up. As you can see, it's that battery that I built in the part 1, 2, and 3. That lithium iron phosphate battery does have the BMS with the Bluetooth, so I can check it when I'm aboard the boat, like when I'm right below it in forward berthing. I'll be able to check the state of the battery to make sure it's all topped off. I'm planning on putting a solar panel on this one, and so one of the issues with a battery this far forward, as you can see my boat, I'm going to go ahead and sign it. It is a Spencer 53, so basically below the hard Dodger there is all the way underneath the deck that you stand on is the batteries for the boat itself. So if I was going to run, and the reason why I'm doing this, to run a cable essentially 40 feet or so, maybe even a little bit more with that, with the height and everything, 45 feet or so of cable from the battery well itself, I'd have to use a really large size cable because it's DC, it's not AC, and DC does have there's resistance in the wire, and so you have to increase the wire size for the length of the run for the amperage. Now the Windlass itself does have a 64 amp electric 12 volt DC motor in it, and so this is a 100 amp continuous duty battery, so it'll run that nicely. I have a good amount of profit in it, or range in it. I will connect up a fuse also in line, probably 125 or 150 amp at the most inline fuse with this. I just want to do this for testing purposes and just to get it initially ready, but I will put a fuse in here. It will be fused. I don't want to short out my motor. My windlass with windlasses do have a tendency to have issues and stuff because they're out in the weather and things like that, so I will put a fuse in line with that. And so the like I said, I'll go ahead and test that here in a few minutes, and we'll run that and we'll show what's going on as far as the use of the windlass itself. Alright. So another thing I wanted to show was this extra wire that I have on the windlass also, because the the windlass itself is just a 12-volt DC and requires just a positive and a negative. But I did use a 3-wire cable. It's a marine cable, as you saw earlier, that I used for that is the right gauge for this windlass. It's a 50 amp cable. And so, but it did have 3 wires. But what I did with the in the battery itself, and you'll be able to hear the windlass kick on. It will run the windlass, and it's not going through the solenoid. So if I had an issue where the solenoid, you can see that where I'm going ahead and connected it there. So I have an issue with the solenoid went out. That would I could use that manually and still bring it up, even though maybe I had a malfunction of my solenoid that's inside of the bell housing for that RC Plath windlass there. Right on the other side of that push-pull switch to operate it is the solenoid. And what you're doing with that push-pull switch is just activating the solenoid and turning it on and off. I know that they do have remote connections that I could potentially put a wireless remote in that, so it's something I'll look at in the future. The wireless remote would connect to the solenoid there instead of that push-pull switch, and that would operate the windlass, and I could do it from back in the cockpit of the sailboat itself. They do have those aftermarket connections for older windlasses like this. And then I did around the connection, you can see the rubber strip with the hose clamp. There's a seam there, so you can take that bell housing off and service the actual electric motor and the solenoid and stuff. I did put that rubber circle on it, and so it's a waterproof seal on that. So when I do take splash, and I know I'll be in situations where I'm going to take splash over the bow, it's just a reality of sailing. This won't ruin the windlass itself from getting water inside of it, and I will make sure that I'll put a cover. I'll make a cover is what I'm trying to say. I'll make a cover for that and put that over it so it keeps it the sun off of it and keeps it nice for a good long time. Alright, I just want to show you the operation of the windlass. And so I'll just use this to pull this up here. Granted, I'm at the dock, so I can't actually pull up an anchor here. I suppose I could put it in the water, but I'm not going to. So just on-off switch here. There you go. There you have it. Fairly functional. I don't have it totally fastened down, like I said earlier, and I'm going to get rid of this houser right here eventually, and I'll have to cut holes in the deck for these housers. I have 2 on the windlass itself, and fasten that down. So I will do that shortly. Put that all back together. So that'll be a future video. I'll finish that up and show that. But it is somewhat functional. I have a bunch to finish up, but just wanted to show you that working itself, and that it is functional, at least to a certain degree, until I bolt it down and it's not really totally functional. So after I get it bolted down and sealed up completely, that'll be ready to go. This right here, is going to use that. It is a shaft support for underneath the boat when it comes out. Usually like this, actually. So when it comes out of the, actually probably like this. Like that, the shaft will come out of the hull, and usually the space, usually stainless steel shaft. It'll go through this just to support it, and then the propeller for the boat back here. So this one is all, you should be able to see that, is all egged out, and so I got it for just like $15 or something like that. What I was going to do is make a stripper using this, so I'll have to cut it. And sometimes when you have a situation where you're lifting up the anchor, the chain wants to lock into the chain gypsy here, and so I'll make this into a stripper and bolt it down also next to, and so it'll just make sure that the stainless steel chain actually goes and falls down through the chain houser on the windlass itself. Like I said, I'll be doing a bunch of deck work here, filling this hole back in future videos, and cutting these holes and getting this totally fastened down and ready to deploy anchor. And then of course I'll put a fuse in line to the battery, so if the solenoid or the motor for the windlass actually short out or something like that, it doesn't ruin the battery or ruin the windlass itself or melt it or anything like that. And then I'll put some loads on it, like the navigation lights and maybe a power inverter, or so I can use it to charge computers and devices like that, some sort of low amperage use thing, just to use the power off the battery, because batteries do like to be used somewhat, like I was saying earlier. So anyways, all right, thanks for watching. That's the windlass itself there. I will connect a solar panel to this to keep it topped off. As I said earlier, I didn't want to run a big, huge gauge wire all the way from the battery rail, which is at the stern of the boat, all the way up here. So this is my solution for that. So I think it'll work well. And plus I could potentially power the navigations light, my important starboard red and green lights for nighttime navigation on the water as required. I think it's a good solution to have that. Plus, windlasses don't actually get used that often, and just having some other load on that besides the windlass that you use only when you're anchoring, essentially, is a good idea. I may go through the boat and into the below decks, which I said was the berthing. Maybe put some sort of simple inverter there so people could charge devices and things like that as well, just to make sure that this battery gets some use, because it's actually good for batteries to have some use occasionally. To have them sit just forever and being charged constantly by solar is actually not that good for them. So I will have to adjust the parameters. Remember, this is a Bluetooth enabled battery that I had in that I built in the first 3-part video that I put out. And so I can adjust the parameters so I don't overcharge it. I can keep it at a lower level. The longevity of batteries, when you charge it to say 85–90% rather than 100% charge, and then even lithium batteries, if you only discharge them, say, to 50% or 40% with lithium batteries, do last longer. Although with lithium batteries, you can charge them, you can discharge them all the way down to essentially almost zero, like 10%, 20% of their full charge. And then you can charge them all the way back to 100, and it will last for, you know, a couple thousand cycles. But like lead acid batteries, the longevity is better if you don't charge them all the way up and you don't discharge them all the way. It's just information on, what is it, batteryuniversity.com. They have a bunch of charts about things like that. A lot of information. It's more of an educational site, batteryuniversity.com. I utilize that quite a bit when looking at things as far as the chemistries. And like lithium-ion batteries have like 5 different chemistries that you'll see commonly used, and there's even more than that are not used at all. So different, really good information, batteryuniversity.com. Again, nothing in this video at all is sponsored, not RC Plath, not any of my battery stuff. This wire was just stuff marine wire I had kicking around and all that. I will put some links to a couple things so you can find them and make it easier for your research, but nothing is sponsored in any of my videos so far. Maybe one of these days I'll get a sponsor. I don't know. We'll see how that goes. And again, as always, thanks for watching my videos. I hope this is informative and you enjoy it, and do let me know if you have something about sailboats or powerboats. Like I said, I do have powerboats also, a powerboat as well with an outboard that I could do some stuff on that. I am planning on doing some stuff with that. I'll probably do some future videos with that as well. All right, thank you.